Okay, it's my pleasure to introduce the third speaker in this session, Chen-Wei Wang from Oxford University Computing Laboratory in the UK, who will present on checking model consistency using data flow testing.
Thank you very much, Paul. So, when you look at the title of this talk, you actually notice there are three keywords in this title. So, model consistency, data flow testing, and then how to check it with data flow testing. So I think the best way to actually understand from a big picture of our approach is to consider this example. So let's say, Paul, you actually say something to me, okay, Jackie, this is what I think about this idea. And then I, as a listener, I will respond to Paul and say, oh, is this what you mean? And then I'll kind of paraphrase what I have understood about Paul's opinion. And then Paul would say, he will have actually two possible reactions. The first one, yes, exactly, brilliant. That's exactly what I meant. The second one, the reaction would be, oh no, not exactly. Maybe I should have mentioned my description like this. And then we'll actually go through this process over and over until he's happy with my paraphrasing of his idea. So now, just imagine that Paul is actually a system developer, and I am the approach of the paper. And he's going to present to me his modeling of the system. And then I, as the approach, will actually consider his specification from the data flow perspective and then paraphrase some testing cases to him. And then he would say, again, yes, exactly, the testing cases reflect exactly what I really understand about the requirements. The second reaction would be, no, not really quite. Maybe I should really fix my model constraint such that the testing cases can reflect better about my understandings. So we'll, again, go over this process over and over again until the point that he, as a developer, is happy with what I present to him for the testing cases. So this is a big picture of the approach. And today I'll talk about the context of this approach. We are going to apply this approach upon information systems. And we want to develop our system by the model-driven approach. Given the model, we want to automatically generate the codes from the model. And we're going to introduce to review the data flow testing technique. And we're going to introduce a new modeling notation called booster. And the unique feature about it is we're going to specify model operations as first-order predicates. So completely formal approach. And our approach is about how to check booster model consistency by using the data flow testing. And I will also conclude and give some future work and some acknowledgements. So first, what's really the context of this approach? We defined the information systems as electronic systems that collect, manage, and provide data that we're interested in. Our emphasis is really upon the data, and also in particular its meaning. How we specify the meaning, we have to specify in a formal way without any ambiguity. And what we really intend to do is, while we only perform some simple transformations on our system, we want to preserve the meaning of the data. And we don't really intend to do any complex algorithms on the data. So let's talk about the semantics of the information system. So there are two kinds of semantics that we can specify about our system. So the first one is about the basic structure of the system, like associations between entities. And the second one is about what kind of properties do we desire the system to achieve, such as the business rules. We have two kinds. And these two altogether can actually document what we really intend for the user to use the system. And what if the semantics is violated? If the first one, the structural constraint, is violated, that means we can no longer interpret our stored data, which is disaster. But in the second one, let's say the basic structural constraints are maintained, but the desirable business rules are violated, we might be able to, we are able to interpret the stored data, but our interpretation might be inconsistent with our original intention. So we have to be very careful about this when we generate the system interpretation. Just consider one example. Let's say we have two attributes in the system. We have age to describe a person's age, and we have years at current address to describe how many years the person has lived in the current address. And if you want to document our intention, we might say one is smaller than or equal to the other. And this is quite important actually, even though that's trivial, because without this, I might have a situation like, okay, I have lived in my current address for 20 years, although I'm only 3 years old. And this certainly contradicts to our common sense. So the lesson is we have to specify some formal constraint to document our intention of use of the system. And what we really want to achieve is to say, once we describe our model, and with the formal constraint, we want the transformation from the system model into the working system is automatic. We want it to be automatic, and this is exactly what the model-driven development approach can promise. We have, in the top level, a specification model, which is both abstract and sufficient. It is abstract because we exclude all the platform-specific information. It is sufficient because it's high level enough. We can intend all the functionalities, all the intentions that we want the users to know. And this point is in particular important. Whenever we want to do analysis, we don't do any analysis upon the codes. We want to do on the specification model. And because, as I just mentioned, the specification model is quite abstract, so that will be sufficient just to do the analysis, and it will be more valuable to do the analysis upon the model as opposed to the codes. Data flow testing. So I'll just do two slides to review on the technique. And data flow testing, since I mentioned, in the information system, what we really worry about is about the data. So that's why we have chosen the data flow testing as opposed to control flow testing. In the data flow testing domain, the focus is upon related definitions and usages of variables. I'll show you one example. And the spirit of data flow testing is to collect for every variable v in your program, and then you want to know some information about it. So you want to collect 3 sets about each variable v. So def v is the set of locations where the variable is actually initialized or modified. So we have changed the value in some locations. The second set is CUs, standing for computational use. So it's the set of locations where we compute the values for v and use it in other computations. And the third set is called PUs of v, standing for predicate use of v. And this is the place where we actually guide the control flows in the program. I'll show you one code fragment. So the last point is what we are aiming for in this paper is to test for every possible execution path for the definition to the usage of the variable. So let's consider this simple code fragment. So here we are trying to change the value of y depending on what's the current value of x. If x is larger than 5, we'll change it to x minus 3, otherwise x minus 2. And then we're trying to decrement x, and then also change the x upon the value of y. And finally, we'll print the value of x. And we will repeat the procedure over and over again, predicating upon the value of x. So, since we got only variables x and y in this fragment, so we consider the 3 sets, as I just mentioned. So def, CUs, and PUs. So, just for example, in lines number 3 and 4, we are trying to change the x of y because it's on the left-hand side of the assignment. And for computational use of y, for example, so in line number y, this is actually typo. So in line number 4, actually, we're trying to use the value of y to change the value of x. So that's a computational use. And finally, for example, here in line number 1, we are trying to use the value of x to direct the control flow of our program. So now, once we got these 3 sets of locations, we can derive the testing cases for our testing. So, just for example, let's say we have 4 and 5. So in this case, we actually change the value of x, and we also use the value of x. So this will be one test case we want to derive. I don't want to spend too much time on this, but that's the idea. That's about data flow testing.